Okay.
So today I'll give you a very short presentation about the suspended graphene-based devices. And in this presentation, I'll give you a overview of the suspended graphene and how to make suspended graphene device. So have you ever heard the word graphene? Yeah.
Not really.
Yeah, really. If you use the pencil, actually you write on the paper, and there's a single layer graphene on the paper, but you cannot see it because it's very tiny and it's transparency, so you cannot find it.
Okay.
So actually, this coolest materials was predicted should not exist because it's thermodynamic unstable.
No.
But this two guy was lucky because they used a very smart method. They used the scoop tip to cleavage the graphite and deposit it on the silicon oxide substrate. So they find the single layer graphene here. This is optical images, and this under the lower magnification, and this is the high magnification. Under the lower magnification, we cannot see the single layer graphene, and we just see this bigger pieces of graphite. It's with the metallic light, and in the high magnification we can see this is the single layer and this is the double layer, and maybe this field layer. So they won the Nobel Prize last year. Yeah. And this is the schematic of graphene transistors. You can see this is the n-doped silicon used and gate, and there's two electrodes, one used and source and another used drain electrode, and when you give a gate voltage to the silicon, and you can measure the ISD and the VSD. So this is the graphene transistor on the top of the silicon oxide. But why we need to make the suspended graphene? Because when there's the interaction between the graphene and the substrate, so it can affect the electron properties, because the graphene is famous for its the electronic properties, because when you the graphene transistors on the unsuspended graphene devices, the electromobility is between the 2000 and 55,000. But if you suspended it, you can got about 200,000. Yeah, 200,000. So, and I have already tried to clean the graphene on the silicon oxide, and you can and use the thermal annealing and the wet chemical treatment, and it also can improve the electron mobility, but cannot reach this value. And if you use the suspended graphene devices, it used as the sensor, you can detect the chemical and biological molecules, and it can with improved signal and reduce the noise. So here's the part how we make the suspended graphene devices. The first step, we deposit the single layer graphene on top of a PMA layer. So the PMA is E-beam photoresist. Actually, it's a polymer. Then the next step is spin coating another PMA. So the single layer graphene was sandwiches in the copolymers, and then we use the E-beam lithography to to define the contact regions. Actually, because this PMA is a long-chain polymer, after the e-beam lithography irradiated, it comes into small pieces and it can dissolve into its develop. After this step, we can deposit the metals. So, like maybe we use the gold to use as the electrode, and then we lift off the PMA, just this part, and we got the suspended graphene device. So here's the result I got. This is optical images. You can see this is this part is the single layer graphene and this is graphite. I don't know the exact layer, but I can make sure this is the single layer, and then we use the e-beam lithography to define the electrode. So then after the metal deposition, and we can find this is the single layer graphene and it's suspended. Okay, so that's all. Because all the steps was finished in the clean room. If you are interested, I can show you around in the clean room. So, or maybe next time I can demonstrate to you how to prepare the single layer graphene. Okay, any question?
What kind of things we can use with the single layer?
Single layer graphene.
Yeah.
Yeah. Actually, if you make the single layer graphene to the device, you can use and the sensor. You can detect. You can detect such as gas and the biological and the chemical species.
Okay.
Yeah.
Thank
Okay.
you.
Yeah.
Okay.